Hello everyone. Today I'm going to be talking about the modifications that I made, new created features. So I added a feature which allows actually for rooms to have host and transfer the host from one to another. And also apart from that, I fixed some backend issues to actually integrate the backend with the gRPC related services as expected. So actually, I spent a bit of time on that, and we'll have to sorrowfully go through each modification and explain what's going on here. Otherwise, it can get easily lost. I'll specify it in the README, but even with the specification, it's a bit tough to actually understand how to deploy stuff. Eventually, after I finish all all modifications, all features, I will actually create automated process of deploying the project. So to make sure that you can easily deploy it like in one go, not in like several steps following the documentation. Yeah, it's a bit messy. So let's start from the host. Let's go to the main client. So here we create a room. We create a room. I added another feature attribute called host RPC address. So this is the host's RPC address that serves as an ID. There was another attribute actually. It was called host ID, if I'm not mistaken. I just deleted it before it saved the dynamic port of a client that created the room. But since host RPC address works fine and easily solves the problem, I decided to get rid of the as one. So basically here we add the RPC address plus semicolon plus client name. This is our identification. Then other places. So in here, transfer host. So this is another function to transfer the host role from one host member to any other available member that is currently in a room. So here we're passing the room ID. So based on that room ID, we're defining the room key. And based on the room key, we're actually retrieving all the host RPC addresses. The RPC address, sorry. So we are getting the RPC address of a room. So basically, we want to find out who is the host of the room. So if it's empty or maybe there are some issues on the database side, on the Redis side, we pop out a message. Otherwise, we print current RPC address, current address. We can get rid of that. Although I no longer need it, I just used it for the logging purposes. So then we verify if the user based on RPC address is the host. So the current host RPC address, we compare the current host RPC address to the current RPC address. The current RPC address is passed to the transfer host in here. So the current RPC address is my RPC address that is set in both create room and join room functions in here at the end. I think no, it was in the main function. I reset it, changed the logic. So where is it? No, here. So when everything is done, when the local client managed to run successfully, right before passing the token to the choice handler and simulate the behavior of the client, we're setting up my RPC address value to RPC address semicolon plus client name. It's our unique identifier for every user in the server. So back to the transfer host function. So in here we're checking whether they're equal or not. If they're not equals, then it's not, then the client that is making a request to transfer the host from him to the other one just sees a message, an error message, showing that he's not the host. Because only the host of a room can actually transfer the host privilege to another user. And after this case passed, check whether the current RPC address equals to the new host RPC address. This is another checkpoint. I mean, if the user wants to transfer the host from himself to himself, it's not possible. So we say that you cannot transfer the host to yourself. Then, if all those checkpoints pass, we're just trimming the new host RPC address. You may ask why. So the question why is that when you pass the new host RPC address from the terminal, sometimes doesn't, so it shows an error on this part on s is member, probably because of some spacings. Probably it reads the slash n when you enter the input. So that's why for the verb for this purpose I just trim the space from trailing spaces and the space on the front, on the very front, from the new host RPC address. So then I send the trimmed new RPC address to this function that checks whether the new RPC address, the new host is actually a member of the RPC addresses. If he is still connected to the server, if he's still alive, if he's not deleted by the server in server.go. In here, in here, it's not deleted from here, then we say that yes, he's a member. So then we pass the token to this part, which sets actually the host RPC address to the trimmed new host RPC address. And this part we set the new host RPC address, we set a new host actually. And again, yet another error checkpoint. If there are no errors, everything just passed well. We return nil as error, so there are no errors. Everything is good. And we continue the loop. So basically, this is the function that I implemented for handling the host. So the host thing, the host feature is handled on the Redis side. It's more of a logical layer rather than uh, hardware implementation, as sending the like sending the messages back and forth between all the clients, like through the host, like having a host so with a separate IP address. So it's not the case. So in our scenario, we use the host as a logical entity that allows for a room management, starting a game, deleting users from the rooms, and all that stuff. By the way, I also didn't mention in the last tutorial why I decided to use actually the matchmaking on the client side rather than having it separately as a separate service in the project. So the reason is that actually my aim when I was creating the architecture of the PulseCore, I was actually aiming at the maximum performance, low latency. So the very goal was to create a lightweight server with the lowest latency possible, considering that I'm going to implement, the channels, special actually features called channels. This is how I call them, channels that you can actually plug in to your rooms and log out, like pull out some relevant data from them. Like can plug in Kafka as a channel, any other message broker, and it has a service. So all this will be working not in real from time to time, periodically, but still it will be another load on the server. So I decided to implement the matchmaking on the client side. There are some drawbacks on that. The disadvantages are security. Security issue is a huge disadvantage. I mean, if you have a matchmaking on your clients, so it's easily to hack the matchmaking, the client side, whether it's compiled to bytecode or not. You can just re-engineer it, decode it, change whatever you want, and basically hack the matchmaking process. If there is some logic on the background regarding the matchmaking, it can be easily hacked. So after finishing all these things, I will work on the security part. I will still remain the matchmaking on the client side, but we'll work on the security part. I have an idea of a thing called snapshot. I'll make sure that the snapshot of the client is validated on the server before running the client. So if even if the client is re-engineered, the bytecode is changed. If it's not validated on the server, the client snapshot, it's not validated on the server, the client won't be able to interact, to connect to the server at all. So this actual approach will solve the issue. And just imagine having a separate secure client on the like separately working on your remote machine that actually delegates the whole load of matchmaking system from the server to the client's machine. This is actually perfect from the performance points of view. Okay, so that was the hosts management thing. So apart from that, so the system, actual PulseCore, works in a way so that you create, a user, then you create an application in that use for that user. The applications they are associated with the real games or any other software that you want to integrate the pool score with. For example, if you are creating a game, then you're creating a separate application in the pool score for that game. And the application also has a separate unique identifier, UUID. So you use this UUID to register to specify your servers associated with that ID. So you can create as many servers as you want, as many applications for the user as you want. So basically, one game basically can have several applications deployed in several regions. So that was the purpose. That was the purpose. So what we do? So here we're reading the server argument from the terminal. If it's not specified, we set it up to PulseCore server. So this value by default. So it's specified and just specify it. Redefine the server address. Write the server in the server address variable. Then we specify the app. Actually, this is the new one. So this is the new argument that I included in this modification. So here you specify your registered application. Application identifier actually. Application, I'd rather call it application ID. That would be better. Or app is just okay. So what we do next? So we read Redis client as usual. So I showed this part in the previous tutorials. Then we check whether the application ID is null or not. If it's null, we just return the fatal message saying that application ID cannot be empty. So basically, you have to specify your application ID in order to find a server that you want to connect to in your account. I mean, this server that you specify, this server must exist in your database, in your account, for you to be able to connect to it. I mean, if you specify someone else database address, sorry, server address, you will not be able to connect to it. Or if the server address is erroneous or doesn't exist, you'll also not be able to connect to it. Then I create two separate functions that are called check application ID, check app ID exists, and check server associated. So basically here we're checking if application ID exists in the database. So we pass the application ID passed from the terminal to it as an argument. Here we're defining the request data schema, table name, columns, conditions. So all the endpoints are defined in the services. I defined them, well, all of them actually, before I started working on the gRPC related stuff, but I just didn't create tutorials for them because they were not actually needed at the time. So here we specify the table name, columns, conditions. So we keep columns as empty. We don't pass anything because we actually don't care about the columns. We rather care about the returned rows. So the table name is applications. So as I showed in the tutorial, before running the project, you gotta run the db setup.sh that'll run the db setup.sql. So sorry, if you're on Mac or any Unix operating system, and db setup.sh, Windows and db setup.bat to run the dbsetup.sql. Here I actually modify the dbsetup.sql. Here I check whether I can create the PulseCore DB or not. If I get an error, such as duplicated database, I just return that database already exists. So regardless the state, we proceed to the following expressions, post SQL expressions. So we switch database to PulseCore database. We create all these tables as all of their definitions that are used by the backend service that I created on the services, both in the database and in the middleware part. So it's crucial to run and create these tables before you actually run into creating your backend and gRPC related stuff. So in here, I specify the applicate table name as applications and the conditions as app identifier. So this conditions actually it's so you say that when you say app identifier and you pass app ID, it equals to where app underscore identifier equals to app ID. So here we're looking for the applications, whether the application exists in the application table. If it does, so we send the post message to this route. So it's deployed using use fancy package. It's actually fairly easy to use it. And it's called Gingonic. It's called Gingonic. I specified my endpoints using it. It's fairly easy, so you just run, this line, this lines, and everything's basically ready. You specify your endpoints, your endpoint handlers by passing the pointer to the Gins context, and you run just using a simple or by calling a simple run function on the port. You can specify the full address. I just specify the port. That actually means that the IP address will be generated dynamically. So we send a message or short serverless. We send a post message to the query with the request data. The query I can also show to you. The query is not database. Query is this. So here's, as you see, it's column, so it's empty. If it's empty, then the columns is just star, which means everything. You choose everything, conditions. You specify here. You go to conditions. You specify them in here, like it means. So basically, you assign like parameters to their associated bounds. So where clause, you specify the values, you append value to values. Then you go here to where clause, you join everything with the and surrounded with spaces. So you're basically specifying a query and passed in here. So here it can be a little bit messy. So when you specify the where clause is the very last one. So request table data, columns, I think it was here if I'm not mistaken. So where clauses, yeah, so it's basically here. You see, so we specify I as one, not as zero, but as one. We specify the columns, we specify the indices, we increment and indices. These are the bounds, these are the clauses, actual parameters. So the thing is that in the Redis library that I used, it's this. So it's no, sorry, right, Redis. So it's the PostgreSQL library. So it's PGX Golang package. So it uses a specific type of queries. It starts counting from one. Like you can specify things like for example, select I don't know, like select name users from users where let's say age equals to one. So one, not this is not the actual age. One is not the age. Uh, One is actually the pointer to the value of age. So here, as you see, I specify query in the query db query. I specify query or query. So I pass the values. The values passed like one by one by using this expression with three dots. So the first value will be assigned to this to the first clause. So to the first clause. Sorry, this word. So to the first one. So it's like the first argument will be assigned to the first value of the values, the second one to the second one, and so on and so forth. So this is how it works. Let's carry on. So you send a message, then you get the response. If there is some error, you just pop it out. There are nods, and you proceed to results. We get the results. We unmarshal the results into our results structure. So we map string to interface. Interface actually means that the value of the map can be anything, can be of any type. So then we return the lengths. So if the length is greater than zero, the function returns true. Thus means the application exists. So kind of the same thing in the check server associated here, we just pass the application ID that exists in our user, that's associated to our user in the database. We pass in the server address, pass from the terminal alongside with the application ID as a second argument. Here we also check we create our request payload that we're sending to the post request. You will specify the table name, columns, conditions. They are crucial to be specified because they're handled on the backend. The backend expecting the following payload. So we fill in the data. We specify table name as server addresses because we have the server addresses database. So server addresses. If we check out the columns. So these are the columns. So basically, address means the server. App identifier is the application that the server is associated with. Tag means the counter tag. So CA means Canada. I just suppose that this server address is associated to Canada. The date created is the creation date of the server. So the conditions is also the same logic. We specify the app identifier as app ID, the past one, the first parameter, the string, and then we send a post request to query the same way as we did with the application ID. We check the errors and we check the results. We unmarshal the results into the results. We get our results. We check whether the address that we passed, the server that we passed, exists in the results. Basically, we're checking the associated servers with the application ID associated servers, and then we check whether the server is in the server list. If it is, that means that our specified server is valid, so we return true. Otherwise, it's just null. So this case is just when it's not found, or so if the server is improper, we just say that it's null. So if it doesn't exist, we just pop out the yet another message saying that there is not such a server associated with the provided application ID. So yes, so if this two cases passed, we just carry on with the rest of the code. We run our client, we dial the server ID, we create a new game servers with the connection that we specified here. We gRPC dialed the server address. We create a connection, gRPC connection with the server address. We create a new client and we allocate another dynamic port from the TCP listener. And here on the dynamic port, dynamic ID, dynamic address in general. So we specify the host as host Docker internal, because here it's the client and the local client. To specify the host as host Docker internal to make sure that both the client and the server are located and operating under the same DNS domain space, IP domain space. Otherwise, it won't just work. The client will be able to connect to the server in the Docker. The Docker won't be able to send the messages, gRPC messages, RPC messages, to the client running on the machine, on the local machine. So this part, by the way, will be changed when I'll be deploying the project, probably in the cloud somewhere in maybe in the AWS or some other server system. So basically, we'll be running. I'll wrap up the client in Kubernetes. We'll deploy that. So this part is not constant. I'll be changing it. So what else? What else? I just modified the readme.md. Here I specified what to run, what not to run. So I specified that there is an endpoint documentation. By the way, I generated public documentation based on the endpoints that you need for the project to work. So basically, can enter the link and go through each one of the endpoints and get yourself familiarized with the system and deploy it. So you can import a Postman or from the local file. There's a local file in the folder, the services, endpoint documentation here. You can basically go to Postman, you can press on import, you can drop it or import the file and to run it. So two versions are available. And I just I modified the client command in here to specify app, your registered application ID, your server ID. The Redis still remains the same until it's also subject to change. So I'll just go through each one of the endpoints. So you see, So you register your user. It's a post request. You specify the email, your password. You send the post request. I already sent all of them. I'll just go through each one of them to showcase how the process will work. So we're doing it before running the local client, as you can see. So we register the user, then we authenticate. When we authenticate, if the authentication pass successfully, it returns the response as token, is the GWT token, and the user ID. The user ID is the user ID assigned to the database. It's needed for creating an application. When we create an application, we copy this GWT address token. We pass it in the headers as the bearer, as authorization key next to the bearer in the value. We'll specify the body, we'll specify the application name, we'll specify the application description. So basically, this is my game, War of Thieves. I'll just quickly advertise the game. You can also play it if I find it here. Games. That's such a nice chance to advertise my game, huh? So it's a 2D multiplayer game. You can just download and play it with your friends. It's actually very cool, very awesome. You can actually have real good time with it. It's very fun. So right. So you create your application. The response is the following body. So I return the app description, app identifier. So the app identifier is the crucial part. This app identifier is set in database. This is what actually associates the application to the servers. So app name, date created, last updated, user ID is one. Alright, so then we create our server. It's another endpoint on the middleware side. So the address, like for now, the address is just a local host address that that bridges to the 1 to 5 port. We specify our app identifier, the one that was generated here. We specify our tag. The tag for now is C8, can be any tag. It's a string. So we send our request. We get our response back if everything went well. There was not any server related problems. So you get the server created successfully message back. So when you will be working on that, just pay attention on the schemas and the endpoints specifically. If you change something in the schema, make sure the parts and on the backend also adhere to the changes on the schema. Because once the schema is changed, if the request is sent, if the backend request doesn't adhere with the schema, that'll just start screaming. So this way we create our application identifier, the servers. So now we can run actually our client. So we specify the application ID. I'll show you the problematic request. So let's change it to 0. We send that there is not such an application. So it'll return that there is not such an application message. So it says, sorry, I didn't run the database along with the middleware. You run the middleware in the database first. I also containerize them in the Docker, probably in the later videos. We allow them through the firewall. Now we run. As you can see, it says that there is not such an app identifier registered. We can keep the identifier properly. Plus 5, right? Just 5. We can change the database. Just say it's 4. Let be it 4. It says that there is not such server registered with this application ID. It found the application ID. Now we can reverse back the server to the proper one. Now it's connected. Now it's working as expected. We can send messages, gRPC messages, we can create rooms. Oh, I didn't showcase the room part. I'll use the chance and showcase it too. No open terminal is bad. Let's open another one. Local client. Let's take the command. So the room is so the room is 12. You can actually automatically join any room. Error joining, error converting box. Oh, there's some bug on the back end. I'll just delete the stop the containers. I changed the schemas and so the schemas that I'm using on the backend side, they on the gRPC side they don't work with the ones in Redis. On the schemas, just key expressions. So that's why it cannot parse some keys, cannot process further in the code. Let's deploy them. Let's check their status. So they're up and running. Cool. Now let's go on to the client side. Uh, oh my gosh, that's where's the command? Anyways, copy it. Let's run it. You can also specify your client name as an extra argument. Here, the client name is specified dynamically. So this is the client name. So let's create a room. Let's say Kingdom. Let's list the rooms. The rooms here. The current room is this. The room name is Kingdom. Maximum players is 10. Current players is 1. Server ID also says associated one. So host RPC address, as you can see, it's host docker internal. So host docker internal actually is the IP address of the Docker desktop. So this DNS, this Docker host Docker internal is the DNS of the Docker desktop. The port is a dynamic one. So for Windows, it's this. Also for I think for macOS it should be the same. For macOS, I just haven't researched on that, but I think for macOS it's exactly the same. For for Linux, as I said in the last tutorial, you probably need to specify an actual port of the locally running Docker host. So here we can automatically join room successfully. I fixed the bug with double join room messages. So so now it works. Current room is this. Okay, our host ID is this, right? The first one, the first terminal. So here the RPC address is the following. We can try to pass the host to this address. We say 10, specify a new host, and a new host is set. So if we try to check the current room's RPC address, host RPC address is the one that we changed. Now we'll try to reverse back from the first client that's not the host anymore. It's not host anymore. We can say host is this. It says error message, you're not the host of this room. This guy is the host. Can reverse back to here. So it's changed now. I'll probably add some successful message on the successful host transfer to make sure you understand what's going on. Anyways, that was the last modification that I made. Just if you have some questions, just ping me up or go through the documentations. I also publish a video on YouTube that I'm recording now that I think that might be helpful. So thank you for your attention and see you in the next tutorials.